Hi guys, today we're going to do a calculus question which is asking us to sketch the function x to the 4 minus 4x cubed. So these questions are sometimes a bit of a trek to do, but we're going to go through it step by step and hopefully it'll help you understand how we go about sketching these kind of functions. So to start with, what I like to do is I like to get the easy things out of the way first. So the easiest thing we can do with this function is figure out where it crosses the x-axis or find out our roots. So what I'm going to do is I'm going to factorize it. So I'm going to rewrite the function like this is equal to x to the power of 3 outside of x minus 4. Now, to find out where it crosses the x-axis, the function has to be equal to 0. And I can use the null factor law to say that for this function to be equal to 0, x is going to have to equal 0 or x is going to have to equal 4. So from that already we have 2 points on our function. We have 0, 0 and we have 4, 0. Great, so what I'm going to do so I don't forget about these 2 points that I've spent all that time finding, I'm going to underline them, just so it's easier to see when we come back to them. Now, the next thing we're going to do is we've got to figure out where the turning points of this function are and what the gradient is doing across the function's domain. So, what we're going to have to do to work this out, we're going to have to get the first derivative of this function. We go about doing that like this. We get the first derivative. Now, I'm not going to go through the actual mechanics of finding a derivative. You'll be able to find that on other videos that I've done. But the derivative of this one is just going to be 4x cubed minus 12x squared. Now, to find turning points or points of inflection, what we have to do is we have to figure out when this function is equal to 0. So what we're going to do is we're going to, like we did before, we're going to factorize it. And we can factorize this by 4x squared. So inside the bracket is going to be x minus 3. So if we want to know when that is equal to 0, we can again use the null factor law. So what we have here is we're going to have x is being equal to 0 or x is being equal to 3. So we have 2 more points where the first derivative is equal to 0. Now we've got 0, 0 and 3, 0. So what we're going to do now is around these 2 points, we're going to have to figure out what the slope of the graph is doing. So what I like to do is I like to draw sort of a pseudo number line. So we'll draw a line. Now what we have here is we're going to have x is equal to 0 and x is equal to 3. Now, at this point here, we know that x is equal to 0 and y is equal to 0. Now, at this point, we know x is equal to 3, but we don't know what y is equal to. So what we do is we substitute this back into the original equation, and what we have is, so we can find what the y value is, x equals 3, so 3 to the power of 4 is 81, minus 4 times 27. So 3 times 27 is 81, so it's going to have to be, if we're going to minus 4 times 27 from 81, we're going to be left with negative 27. Great. So what we need to do is we need to figure out what the value of the gradient is before x equals 0, between x equals 0 and x equals 3, and then after x equals 3. So what we're going to do is we're going to sub in each of these, a point from each of these different situations. So from x is less than 0, let's sub in x is equal to negative 1. So we can just write for x being less than 0, So I'm going to sub in x equals -1. If we sub -1 in here, -1 cubed is still -1, times 4 is -4, minus, now we've got -1 squared is +1, times 12 is +12, so minus 12. So we've got -4 minus 12 is -16. So what we know then is that the first derivative of x is going to be less than 0. So we know behind this point we've got a negative first derivative. Now we're going to go for x between 0 and 3. Let's just pick a point, x equals 2. If we substitute 2 into this equation, we've got 2 cubed is 8 times 4 is 32 minus 2 squared is 4 times 12 is 48. So 32 minus 48 is a negative number. So we can say for x is between those, the derivative is still less than 0. So here it's negative. We know that the derivative is 0 there and there. It's going to be negative in between. Now let's do for x greater than 3. Cool. So what we can do is for x greater than 3, we just now if we put 4 into the first derivative function, we get 4 cubed, or 4 times 4 is 16, times 4 is 64. Then we times that by 4. So 64 times 4 is 256. Subtract 12 times 16, which is 192. So 256 take 192 is going to be a positive number. So the first derivative here is going to be greater than 0. So we can put in our plus point there. So you can see from this sort of line here, we have the graph has a negative slope, it then has a 0 slope, and then it has a negative slope, and then it has a 0 slope again, and then it has a positive slope. So it's quite easy to see, now I'll just put this in a different color, that this point here, if you look at our lines, is going to be a minimum. And this point here, because it goes negative, 0, negative, this point here is going to be a point of inflection. Because you can see that it goes from negative to 0 to negative. So it's not, there's no minimum there or no maximum. It's a point of inflection. So where the concavity changes shape. Now, speaking of concavity, what we need to do is we need to figure out how the slope changes over this domain. So what we're going to do is we're going to take we'll just separate them out a bit. We're going to take the second derivative. So the second derivative of x is going to be equal to, have a look at this one, 4 times 3 is 12x squared minus 24x. Now, we can find out when this one equals 0 by factorizing it. We're going to have 12x outside of x take 2. Now that's going to equal 0. Now again, null factor law, we're just repeating ourselves. So at this point, we're going to have x equals 0, x equals 2. So we already know that y is equal to 0 at this point. What we can do is we're going to work out what's happening here. We substitute this into the original equation, which is here. 2 to the power of 4 is 16. Subtract 2 to the power of 3, which is 8, times 4 is 32, so 16 take 32 is negative 16. Great. So what we have is we've got the second derivative. When that equals 0, we have what's called point of inflections, or changes in concavity. So what we're going to do, like we did with the first derivative, we're going to draw a number line. We're going to put in our points where the second derivative is equal to 0. So it's a lot easier to when you draw it right at the end if you are able to put a lot of these numbers underneath each other. So we have x equals 0 here, and this is going to be y equals 0. Now we have x equals 2, so here's x equals 3, so x equals 2 is going to be around about here. X equals 2, y equals negative 16. And here the second derivative is 0. So this confirms that we have a point of inflection at 0, 0, because they match up. Now, like we did with the other ones, we have to figure out what the concavity is of the function before x equals 0, so x is less than 0, between x equals 0 and 2, and above x equals 2, or x is greater than 2. So what we're going to do is we're going to substitute numbers into this equation like we did here. What we'll do is we'll move this over here, and we'll go back to the same colour. So we're going to start with 4. X is less than 0. F double prime of x is going to be, so we put x equals less than 0, so why don't we just make x equals negative 1 again? And we'll put that into our second derivative function. So negative 1 squared is 1, 12 times 1 is 1, minus 24 times negative 1, so it's minus 24, so it's going to be plus 24, so we have 12 plus 24 is 36, so this is going to be greater than 0, so we can put a plus here. We can then go for x between 0 and 2, the double derivative of x is going to be, so why don't we just put x equals 1 in? So we have 1 squared is 1 times 12 is, well, 12, minus 24 times 1 is negative 12, so this is going to be less than 0. Great, so I just put x equals 1 into this one to make it work. So this is going to be negative here, so this is going to be concave down. Then what we have is we have to have x equals greater than 2. So for x being greater than 2, I'll put just x equals 3 in. We have 3 squared is 9 times 12 is 108, minus 24 times 3. Now 20 times 3 is 60, 4 times 3 is 12, so it's 108 minus 72. So it's going to be a positive number. Great. So this is, we can say that the f double prime of x is going to be a greater than 0. Good. So what we can tell from this function is it's going to be concave up here. It's going to be concave down here, and it's going to be concave up here. Great. So what we need to do, now we've got all of this different information, we need to actually draw the thing. So what we're going to do first is we're going to draw some axes. So here is the x. And here is our y. So we have x, f of x. Cool. Now we'll draw it a different color. Now let's just go through and mark all our key points onto the graph. So we know that the function passes through the points 0, 0, and 4, 0. So those are our two roots. So there's 0, 0. And I'm going to make 4, 0 across here. Great. So those are the 2 points we can get from the original function. We know that there is going to be a minimum at 3 and 27. So what we can do is we can put that one in. Negative 27. So we'll make 3 there. We'll make negative 27 down here somewhere. If it's a minimum, it's going to be our lowest point. We write in the 3, negative 27. We know that there's going to be another 0 gradient here. And what we can get from the second derivative is we know that there's going to be a point of inflection at 0, 0. So there's a point of inflection here as well as 0 gradient. And there's a point of inflection at 2, which is going to be here, and negative 16, which we will put there. So this one here, we'll just write it in. This is 2, negative 16. So what we know is we know that it has a negative slope but is concave up. So it's getting less negative from here. So the way we're going to do that is like that. It goes to 0 slope and is concave down from here to there. So the way we're going to do this is I'm going to start it here, and I'm going to, oh wow, I'm going to try and get it to, oof, this is very difficult with the software that I'm using. You get my drift, so it's curving down. Now from here until positive infinity, it is concave up. So it is going to change from going down to curving up from here. So we start curving up, and then we curve, make sure it's continuing to curve up. The gradient is positive. We go through our 0 point, and then we continue our positive gradient ad infinitum. So it's important as well that we label all of our key points. You can see that this is a point of inflection and as well as a 0 gradient. We have another point of inflection where it goes from concave down to concave up at 2, negative 16. We have an absolute minimum at 3, negative 27, and another root at, this is going to be 4, 0. So what we've done here is we've used calculus to determine the shape of this graph, and we've identified its key points. So I hope this video helped, and I'll see you again next time.